everybody. Good afternoon. My name's Chris Little. I'm out of the Bedford office. Thanks for hanging in there, everybody. Right now we have Glenn Wadden, who will be telling us about either IoT or IIoT. Do we have time for the second I?
I think we might be able to squeeze
Excellent.
another thing.
It's going to be a treat. So take it away, Glenn.
Okay, thank you, Chris. This is possibly going to be a relatively short presentation, but I think it's a worthwhile one to bring up because there's a lot of buzz in the media, especially the media and control engineering type magazines, where there's a lot of talk about IoT, IIoT, and what it all means. So I'm going to try to kind of get at that and try to clarify, I hope, what's behind all of that. So what is the Internet of Things? What does it really mean? So it actually means that there's a lot of things that are really common and actually the same as SCADA. But it's called IIoT, and the differentiators, the things that classify it as being IIoT versus your typical thought of SCADA, are that often IoT runs in data centers as the servers rather than in a premise-based system. So the data centers, meaning cloud, or co-location. Co-location is just another data center that has your servers instead of Amazon's in there. So that's one of the distinctions. Now, SCADA can run on a cloud server. Internet-based communications is another characteristic of what people consider IoT. Internet-based communications, again, nothing that's apart from SCADA, but SCADA has often been running on radio telemetry. I met a couple of weeks ago with a company called Census, you're probably aware of them. They'd make automated meter reading systems. They call themselves an IoT system. They don't use internet-based communications. They use a radio-based telemetry system that connects into a... I hear noise in the next room, it kind of confuses me. They have a private radio channel, basically licensed radio channels that come into their concentrators. They go by that to an internet connection. But this internet-based communications is sort of a general characteristics. What you call IoT, what's SCADA, is a little subjective, we'll say. But here are some of the things that are characteristics of IoT. Low frequency data updates. So plant data where you're updating things once a second, once every few seconds, that's kind of, people would categorize that more as SCADA. IoT stuff, it's more likely every hour kind of data. So we, back around 2000, we had a system that we would probably classify now as IoT. We monitored for a customer, basically a series of gas customers, cryogenic gases, liquid nitrogen, liquid oxygen kind of gases. And they had assets available all around the world. So we were monitoring these tank levels. These tank levels were coming in by a whole series of different mechanisms. But because of the nature of the data, tank levels didn't change that often. There were 20,000 assets around the world, everything from CO2 levels at a Pepsi plant in Paris to fish factories in Norway to the hydrogen levels in the space shuttle fueling systems. They're all coming into these systems. The data update rates are still very low, once an hour. So that's the kind of typical kinds of things you see in an IoT system. Remote assets, again, a remote asset. You don't find IoT as being something that's connected by a wire across the building. It's something that's out there, remote internet. Small I/O count at each installation. When we talk about these tank assets, they measure the battery level of the RTU, top level tank pressure, and the level. That was it, three. That's all you got. Limited control. So it's almost an exception to have any kind of control action in a system which would be categorized as IoT. Now, having said that, all of these IoT things are really just restrictions on a SCADA system rather than characteristic of being something special. Similar data at each location. It's kind of like lift stations. They're all pretty similar. Tank levels, all very similar. That's kind of characteristic of IoT things as well. So the kind of things that you would see lumped into the IoT world will be things like people's cell phone location, GPS location on cell phones. They used to see how much traffic is moving on the highways, gathering lots of data, all similar kinds of data scattered across a larger area, relatively slow updates, not once a second, and from that they can figure out traffic patterns, where people are. Interesting kind of applications. So not that it's crazy applications, but it's just a slant on this that tend to be consumer-centric kind of applications versus industrial kind of applications. So Internet of Things that's the spin on it, or the way people talk about IoT, that's what they're thinking about. These kinds of aspects of it that are SCADA aspects, but they're different slant on the SCADA world. And they tend to be, the whole thing evolved out of an IT culture versus an industrial culture. I think that there are server-based systems that people had ideas about collecting cell phone data and aggregating it. It was all based on this idea that, well, we can use our data centers to do it, and we can aggregate data across the internet, and we can do things, and they all converged on the idea that this is all these great things we developed, which is really parallel to SCADA, which really is SCADA. Then they came up to the idea that, well, if someone's cell phone doesn't deliver me data on their GPS coordinates, nah, not so bad. I still have thousands of other people out there who are giving me data that's important. So Barry here and Keith, it's I think in one of the other rooms, as they ran into one of the IBM people in a show in England some months back, and the IBM view of the world was that IoT really means people are not that upset if the data doesn't arrive. It's not mission critical kind of data. It's just interesting data that I can use collectively to figure out something. Having said all that, I want to show you something sort of more or less real and how the IoT world would see things going together. Now we have a sensor. In this case, I've got, and there's no way you can see this, on the end of this little circuit board there's a little temperature sensor. Connected to that, there's this little Arduino computer. This Arduino is just a little microcomputer, has Wi-Fi on it, reads this sensor, sending the change in temperature by a protocol to my Wi-Fi hub on my table over here. So this is a, kind of a characteristic of what you might see as a small sample of simple information that's collected via an IoT kind of technology. So if I look at how this works, sensor here goes into this protocol system called a broker. MQTT is the type of protocol that's often used on these IoT systems. There's nothing that makes it peculiar to IoT. You can use it for SCADA as well. And people tend to think of it like DNP3 or Modbus. It's just a protocol, something like that, except that MQTT really isn't a protocol per se. It's kind of like TCP/IP or serial connection. It's a way of packaging the data. It doesn't describe how the data, so you need a little more information to say more than, oh, I've got an MQTT driver. You really don't have enough information to know how to interpret that data. It's just a package for delivering some data. You could put Modbus through MQTT if you wanted to. So it's just a different way of packaging it up. Often these MQTT packets deliver the data in a format called JSON, J-S-O-N, which is a JavaScript object notation, which is a common internet kind of encoding of data. It's a text-based kind of solution. Fairly flexible, not very compact when it comes compared to Modbus, but it's a very universal kind of way to express data. So It's often used and transmitted over MQTT. VTScada has a JSON driver as well built into it. We have a MQTT driver in VTScada, which is the right-hand blue arrow, allowing us to connect into this MQTT broker. Now I'm going to show you a picture of the broker that's running on my machine. This broker is a little bit of a confusing term, I'm sure. I'll try to clarify. This is what the broker looks like in the control. This is a little simple one that comes out that's free. It's actually called Mosquito. Mosquito is just a separate program running on my machine that allows this little device here to send commands to the broker, and my machine on VTScada is connecting into that broker and what they call subscribing. So this device publishes data, so it connects to the broker and says, I have this kind of information, and it pushes it out to the broker. VTScada may or may not be connected at the time. When I connect to it with VTScada, VTScada says, I'm interested in this temperature data for the Embassy Suites temperature. When it changes, send me information on it. It's not changing on the bottom. If I blow on it, I'll change the temperature. You see rapid changes in temperature in the thing. That's this device pushing data through the broker. Crude interface, but effective. Now if I go back to my architecture drawing here, so we've got the sensor publishing data to the broker, VTScada subscribing to that data. One of the characteristics of this architecture is that VTScada may be one of several different subscribers to that data. So in an IoT world, you might have a different piece of software, could be accounting or something else that wants that data, and they could also subscribe to that data and get data from the broker as well. Now if you change the names on the boxes, it might become somewhat clear that the sensor is still the same, the protocol is different. The middle box you could relabel OPC, and on the right hand side you've got your SCADA package, your HMI. So OPC is basically the same kind of concept where you subscribe to the data, the OPC server pushes the data out whenever it changes. So it's a publish subscribe model, just like MQTT broker. So it's not like they're foreign concepts or new things that have been rolled in. So another way of stating it is that this is just another way of doing communication protocol that isn't terribly inventive, but it is a little different than your standard Modbus device that connects directly to your I/O. Now I'm going to pop up my little temperature meter here, because it is interesting. One of the things that it has with its publish subscribe concept is a lot like DNP3, fatter, meaning less efficient. But like DNP3, when something changes, it pushes out the change versus having to poll all the time to check. Temperature's not changing right now, 75.5 degrees. No bytes are going across the wire or at all. If I breathe on it, we have some bytes moving. As it cools off, it comes down. So it's got that nice throttling of bandwidth. So it can work in a somewhat a real-time environment as well. The difficulty is that you're not looking at packets of data like you are with DNP3 or Modbus. With Modbus, you're polling, you're getting 100 registers at one time. You're getting 100 I/O in one poll. At MQTT kind of option, you're getting one reading going through typically at a time. It's not necessarily so. You could, because it's a packet of data, you could kind of bundle in whatever information you wanted into that bundle. But typically you're going to send out very small packets of information at a time, which means when you're dealing with 10,000 I/O, you could have a lot of different things chattering on the wire at the same time. So the industrial Internet of Things IIoT is something which we may have heard of. It's actually the same kind of idea, except that they said instead of all these commercial activities, we'll say it's all about industrial stuff. Okay, throw away all the information about commercial. Same thing on an industrial scale. What we're talking about here with room temperatures could be an industrial kind of thing. If I'm looking at HVAC systems, and you know that you're interested in room temperatures, you're looking at compressors, and you're looking at fan speeds or whatever else is in the building that's important. So that could be all industrial kind of applications. So same kind of thing, not in a plant typically, but typically more monitoring remote assets. So industry-centered IoT, industrial IoT. So we get the kind of things like, as I mentioned, the tank monitoring systems. We know that we've heard of these airline crashes where the engine manufacturers monitor their engines remotely from a central location through satellite things. That would be more of an industrial IoT kind of thing. One of the things that's interesting about the IoT world is that they're very interested in metadata versus process data. I gotta clarify that a little bit, but metadata is the information about the engine, how it's operating, where the pilot's not worried about that. They're worried about, is it keeping the plane in the air? How much thrust I have to get out of it. So not measuring thrust directly. They're just controlling the throttle like you are in a car. You have gauges to let you know when something's going wrong. That's the metadata about driving. But driving is not about watching the gauges. It's about using the steering wheel, the gas pedal, the brake, and looking at the window to make sure everything's okay. Metadata is about coolant temperature and the radio channel, this kind of things that are related to the actual operation, but it's the surrounding equipment and it's collateral information. So often you'll get IoT or industrial IoT things looking at maintenance kind of data, preventative maintenance kind of data. They'll look at the pump, not from what it's producing, but how the pump is behaving. Its efficiency is dropping, therefore I should be putting in work orders now to, do some maintenance on that pump versus waiting till it fails. So it's the metadata kind of things that are centric in the IIoT world. Again, not exclusive. Everybody's got their own bent on it, but that's what I see. So one of the things, a lot of misinformation I see on the internet about IoT, and these are some of the comments I pulled from the internet just to give you some idea of what people are saying and proposing, what they think SCADA is versus IoT. And I've heard these verbally too, and I feel like pounding my head against the walls sometimes, but I'll kind of let you read through them. One of the things that say SCADA is limited to only proprietary devices. Well, obviously that's, they're thinking about the old days when there's a SCADA, a DCS system where you're tied to a particular type of I/O and a particular brand of human-machine interface, or it used to be called man-machine interface back in the 70s. So these limited proprietary devices are obviously SCADA systems talk to MQTT as well. Data storage limited. One of the things that is said, if it's in the cloud, so you have unlimited storage. A typical SCADA system now, we say you buy a 1 terabyte solid state drive, Samsung enterprise grade, $450 or less, which will store at least 20 years of historical data on your machine, and by that time you can probably buy a bigger one. We just brought down with us, and Chris has on his tabletop there in front of him recording our videos, that that's a 4 terabyte drive that came for $139. Storage space is not a problem for SCADA systems. We can store data, and not just VTScada. We can store data for many, many years. There's no thought of having to, well, data's only good for a month before it rolls over. That's decades old thinking. SCADA systems don't run on cloud servers. That's another thing that has been put out there. Obviously, it's not true. Since 2000, we've been running on cloud servers. We have a number of customers out there today that are running on cloud systems, running VTScada. Could name a few, but I can just, off the top of my head, there are. Even in Dan's area there, we've got some, Kennedy Industry, Metropolitan Industries, Well Optics, Antix, Xylem. A number of customers are all running cloud-based systems based on VTScada. Where the SCADA system runs, I think, is irrelevant from differentiating it from IoT. Can't do analytics on the data from a SCADA system. I don't know where that idea came from. Data is data. If it's local, it's easier to get at than if it's remote. Tons of data. You can do whatever you want with your data. Can't collect ancillary data or metadata with a SCADA system. Of course you can. If you need to know what the running hours on the pump are, you have that. You need to know all that kind of stuff. So these are the kind of, I directly lifted these from websites to say this is what SCADA systems can't do and why IoT is good. Obviously, SCADA systems can't scale to a large number of I/O. Other ones. So our biggest system is the British Digital Television System. I think it has 1.25 million I/O. It's running on a 32-bit system. That's typically because it's optimized for that purpose, but still, SCADA systems in general aren't really limited by I/O. So there are, I want to throw that out there because, again, there are proponents that would suggest that IoT and SCADA are completely different animals. IoT is the way to go, SCADA is dead. My perspective is that IIoT is SCADA. It's just a different spin on it, different emphasis on different pieces of it. So that's where my 2 cents worth. I say it's not going to be a long presentation, but there's some stuff that's worthwhile talking about. This is another aspect of the whole game that is an evolutionary thing that IoT is sometimes in the IIoT has been relabeled, or coming out of Europe has been coined a phrase called Industry 4.0. And the concept being that when you put steam power in, you got the Industrial Revolution, Industry 1.0. Industry 2.0, you add electricity rather than steam power, and then you get mass production. You add in computers, you got SCADA in there, you got the Industry 3.0 model. Industry 4.0, you throw internet on top of it, and they call it IoT, but it's just basically SCADA with the internet, and you've got Industry 4.0, the next revolution in the industry. And there is an industry revolution that is being fueled by this internet, and it's not just the internet. The industry revolution is being fueled by things like this, that this little computer here is literally like $6. So runs on little USB connection. So the fact is, it's just an indicator of sensors are becoming really cheap. I/O communication is becoming really cheap. The connection is becoming really cheap. So what happens is that people are putting more data out there because it's cheaper to put more data out there. I can get more data. Now you have to throw it all into the computer. So I gather more data. What am I going to do with all this data? I'm going to have to gather it through the internet. I'm going to have to do some analytics on it, and I need to be able to manage all that configuration. How do I manage all these configuration systems? So one of the things that we had done many years ago with this tank level monitoring system was that the supplier of the RTUs for those had a concept they called lick and stick. They just had a threaded connection on these things. They wanted the truck driver that was delivering the gas to these tanks to basically thread a RTU onto a pipe, had one button on it, they pushed the button, sent a message up to the communication system which came into VTScada. It automatically registered that with the system, and it was online. It was just like automatically create your tags, put it in system. And that's the kind of thing when you're pushing out 20,000 plus devices out there, 20,000 remote RTUs, you have to be able to manage that kind of thing. So there's always ways of handling it. So the templating, parameterized modules, that kind of thing is all about scaling up to handle all of the push that comes from cheap I/O, cheap communications. And it was a big deal to put in a phone line to connect to and remote tank it sometimes. And maybe some of you can remember back in the days where this, I think it was a 4 to 12 second Bristol metameter, you needed a dedicated phone line to send one analog signal along. That was an expensive way to send one signal. It's not that way anymore. So anyway, I think there's some stuff to be learned there. Time for questions. We have a driver that is not yet released. Right, well, if you're asking about security on MQTT, well, MQTT is not particularly secure. The ones we have right now, I'm looking at this Mosquito. One of the concerns you might have on that particular broker is that the data is published into the broker. Anybody can subscribe to the data, like anybody that can access that broker. And typically these things are in a cloud or on the server somewhere. So that's not the best way to run your world, but it doesn't have to be out in the cloud, but just anywhere that's on the network. So you start having to put in layers of security on top of it with HTTP, VPN connections or so on to make some logical stuff. But you could argue the same thing about Modbus and DNP3. They're not secure inherently either. Anybody that can get on the wire and listen to it could eavesdrop on what's going on. Sensor limitations, what kind of sensor limitations we've seen with the brokers? There really are none. So you could put anything through that you wanted. So there's nothing inherently about MQTT or IoT that would suggest that you can't put, you know, pressures, flows, speeds, levels, weight. The number of sensors? No, the idea is that they're looking for generally a wide area of large number of sensors. If you're in a production plant, it's probably not the best choice for a protocol. But if you're going to have data scattered across a pipeline maybe, or an electrical distribution network, well, it might be something to consider. Yeah, the control aspect too is also a little bit insidious, because if you go back to that first slide, if you look at the broker, there is no guarantee that the RTU is actually connected to the broker, even though we are connected to the broker as VTScada. We can communicate with the broker. We can send out a control command, publish it to the broker. We have no idea if there's any RTU listening to it out there. There's no loss of connection indication at all.
I thought there was actually, sorry, disagree. I thought there was a loss of connection. I thought it let you know that they had this expired or coffin or dead type terminology.
Yeah, they have a last will and testament kind of thing.
Last will and testament, yeah, it's actually called last will and testament.
Yeah, but you don't know that. You published it and it's gone, you're shut down, you think it went.
Well, it's last will and testament of the integrator put it in. Right.
So we were building the sorting machine for Amazon, and they don't even believe on Windows IoT. Let's set up the SCADA. Let's, do it through Mercury protocol or whatever, standard that they have to communicate with their distribution center, and also monitor everything with a lot of sensor, RFID sensor on the package or barcode or whatever. They don't want to distribute that through the IoT or IIoT and through the internet, because it's not reliable for them. It's not real time.
Right.
So that's
I think IoT is just a subset of SCADA. It's actual sort of real SCADA applied to a different kind of market in general. Low data volume. Loss of data is not that critical. That's the kind of application it works. Cheap data is kind of the general theme. But another way to look at it is just SCADA. All right, thank you for coming.